This is the beginning of lesson 1.3 in algebra. I'm going to start with a quiz. If you're taking this at home, you're going to want to pause here and take the 5-question quiz. All right, you may correct your own for now. You need a red pen or something other than the pencil that you just used. All right, number 1, it says write a variable expression for the number of days in X number of weeks. Here's the deal. When you get a question like this and you're like, I don't really understand, think about this. Just change the word of the question a little bit and you'll get it. Instead of X, that's probably the part that's going to get you. If I said, what if it was 3? What if they write a variable expression, or write an expression for the number of days in 3 weeks? How would you write that? How many days are there in 3 weeks? 21. How'd you get that? 3 times 7, right? 7 times 3. Okay. Well, what about 4 weeks? What's the answer? 28. How'd you get that? Oh, 7 times 4. 8 weeks would be 7 times 8. 10 weeks would be 7 times 10. So then X weeks is 7 times X. The pattern doesn't change, right? So the answer to number 1 is 7X. It could have 7 times X, whatever. Number 2, M less than 4. Less than, right? So then you tell me what is this expression? How do I write this? 4 minus M. Got to be in that order. 4 was there before the M. Your M less than 4. 4 minus M. Number 3. Do you see any parentheses? No. Exponents? No. Multiply or divide? Yes. Which one do you do first? 2 plus 12 is 14, right? 14 is the answer. Number 4. Do you see any parentheses there? How many? 3. There are 3 sets of parentheses there, right? That one, and that one. Anyway, do the whole top. Inside of those parentheses, you see another set of parentheses, so we're just going to go like this. We're going to go 9 times 7 on top. 9 times 7 on top. The bottom is 25. Well, you do 5 squared first, right? 25 minus 4 is 21. Right? So it's 63 divided by 21, which is 3. I guess that's fine. Should reduce it. Number 5. A is 4, B is 6. Rewrite everything. When you plug it in parentheses, right? So 2 times 4 plus 6 squared divided by 3. Okay. In here, do you see any parentheses? Yes. What is 6 squared? 36. So it's 2 times 4 plus 36 divided by 3, which is 8, plus 12, which is 20. Now, all right, we are now doing algebra lesson 1.3, which is properties of numbers. Okay. Here's the deal about this. I'm not a super stickler that you can name every single step on any string, because it's simply too. It's not important that you can name every single property and every single set of order of operations, etc. You just got to know what you're allowed to do, right? That's the whole deal. You have to be able to know what you're allowed to do, and that's why we go over these things, so that you go, oh, I now understand that's the reason why I'm allowed to do this, because of the blank property of blank. Anyway, so here we go. We're on page 16. Here is some properties that you need to be aware of, okay? Notice this. Let's read the top of page 16 where it says properties of equality and identity. The expressions 4k and 8k and 12k are called equivalent expressions because they represent the same number. The properties below allow you to write an equivalent expression for a given expression. Okay, here we go. Ready? The reflexive property. The reason why I don't make you memorize this is because the reflexive property, here it is. This is what the reflexive property is. Are you ready? Is that 3 equals 3. That's what that property tells you. That, a number does in fact equal itself. Do you think you should memorize that one? I think you probably already have. Let me look here. Look at the transitive property. Actually, you use a lot, which is the third one down. It says if one quantity equals a second quantity, and the second quantity equals a third quantity, then the first quantity equals the third quantity. Does that make sense? You'll use that one a lot. I mean, like it's only logical. But that is one that you'll use. If A equals B and B equals C, that means that A equals C. Does that make sense? I mean, and I know that sounds obvious, but you'll use that when you start proving things in geometry and stuff. So anyway, the substitution property. Here's the deal. This is what we just did, really. It says that a quantity may be substituted for its equal in any expression. If A is B, then A can be replaced by B in any expression, right? Just like if A equals 5, anytime I see A, I can substitute it with 5. Does that make sense? Then I'm allowed to do that. Okay. I don't care that you know the words here. I really don't. I'm not going to make you memorize any of those words. None of them. But you need to know you're allowed to do this. Okay. There's one type of property that is called the additive identity property. We're in the middle of page 16. The bottom of it, actually. The additive identity. It says here that any number A, that the sum of A and 0 is A. In other words, the additive identity property means that if you add 0 to a number, the number is still the number. Okay? So 5 plus 0 is still equal to 5. X plus 0 is still equal to X. Whatever you add, the additive identity property, you add 0, it's still equal to that. Again, I mean, you've known these rules for a long time. Agreed? You just may not have known it was called the additive identity property. Now you do. The additive inverse property, a number and its opposite are additive inverses of each other. In other words, and this is a good one. If I have 5 and I add negative 5, what does that equal to? 0. You take a number and you add its opposite, or its inverse, it's going to equal 0, right? So if I have, 17 and I add a negative 17, it's equal to 0, right? So, and I know that seems obvious, but sometimes you get to the point where it's, x plus negative x, and you're like, no, it's the same property, right? X minus x is 0. Okay, when you add, and notice this, remember this all goes back to the fact that, what is the difference between 5 minus 4 and 5 plus a negative 4? What's the difference again? Nothing, right? Subtraction is addition. It's still addition, right? Subtraction is, you can still write it as an addition problem. You're just adding the inverse. We talked about this last year, remember? Being able to do that's a big deal. Like it just helps a lot. Okay. There are a few multiplication properties. Okay? The multiplication identity property is the one that says if you take a number and you multiply it by 1, what do you got? It's still that number, right? No matter where it is. 17.3 times 1 is 17.3. Negative 424 times 1 is negative 424. XY squared times 1 is XY squared, right? You multiply something by 1, it doesn't change the identity of it. That's why it's called the identity property. Remember that. If you want to know, and I do use these a few times, the identity properties are easy. It means that the number doesn't change its identity. Remember that. It'll help you. Any of the identity properties, addition or multiplication, it means that whatever you did to it, it didn't change the number's identity. Okay? The multiplicative, everybody say, so listen, you got multiply, right? But multiplicative property of 0 means that, what do you think the multiplicative property of 0 means? Any number multiplied by 0 is 0. Negative 7 times 0 is 0. X, y squared, z to the 512 times 0 is 0, right? 4x to the 5th, y to the z power over negative 14.625xyz. All of that times 0 is 0, right? Anything times 0, 0. Multiplicative property of 0. Now, the multiplicative inverse for every number a divided by b, where a and b are not is 0, there's exactly one number such b over a such that the product of a and b of a is 1. Okay, here's the property. You know this already. You do know this. If I have 4/5 and I multiply that by its inverse, 5/4, what's the answer going to be? 1. 31/6 times 6 over 31. You know that I've taken these and I've just multiplied it by its inverse. What's it equal to? 1. X over y times y over x is 1. Okay. When do you use that a lot? When do you use that? When should you use that plenty? What if I have 1/3 x equals 4/5? What did I use? Well, what could I do? I'm trying to get x by himself, right? What's the quickest and easiest way of getting x by himself here? Multiplying both sides by the reciprocal, which is 3 over 1, right? Multiply this by 3 over 1, this by 3 over 1. What does this 3 over 1 times 1 over 3 become? 1. And 1x is just x. You see what I'm talking about? Okay, another set of properties is the commutative property and the associative property. The commutative property means what? What's commute mean? Move, right? So you've got the commutative property of addition and you have the commutative property of multiplication. Here's the deal. If I have nothing but 5 plus 6 minus 3, am I allowed to move all those things around? Yes and no. You can't just go 5 minus 3 plus 6. I don't think you can. Hold on, maybe you can. My point is that you got to get them to be all addition, right? In other words, you can't, okay, this is what I mean. You can't just go like this, 5 plus 3 minus 6. You can't just move the number itself around. What you can do, though, is you can know that this is really that, right? And now, since all three of them are addition, what is 2 plus 5? What is 5 plus 2? I can move them around, right? What is 5 plus 6 here? 11. 11 plus a negative 3. 8, right? Okay, well now let's move it around. Let's move the negative 3 out front and go plus 5 plus 6. What is negative 3 plus 5? 2. 2 plus 6? 8. Because it's all addition, I can move this stuff around. Make sense? I can commute them. Same exact thing with multiplication, right? Same exact thing. 3 times 2 times 4. What's 3 times 2? 6 times 4? 24, right? Can I go 2 times 4 times 3? What's 2 times 4? 8. 8 times 3? Still 24, right? I can commute them. I can move them around. What if there was a division portion of this? What could you do? Like if all of a sudden, what if there was a 3 times 2 divided by, we won't do that. We'll do 3 times 4 divided by 2. Can I move stuff around? Here's the answer is yes, you can, but you got to know that divide by 2 is the exact same thing as multiply by 1/2, right? So this is really 3 times 4 times 1/2. And now can I move things around? Absolutely. Make sense? Commutative property of multiplication. The associative property. The associative property means this, that the order that you do things in don't matter. Okay? This is the only one that I don't have a good explanation for, associative. If I have 2 plus 3 plus 5, that, if I go like this, is the same as 2 plus 3 plus 5, meaning that on this side, I'm going to add the 2 and the 3 first, and on this side, I'm going to add the 3 and the 5 first. Guess what? They're the same, right? The associative property means that it doesn't matter what order you do them in. Now, what if I was to all of a sudden change this to 2 plus 3 plus 5 times 2? Can I now all of a sudden move things around and go 2 plus 2 times 2 plus 5 plus 3? Can I do that? No. The only time you're allowed to use these properties is if it's all addition or if it's all multiplication. Does that make sense? It's got to be all or the other. If I have nothing but a string of multiplying, 2 times 3 times 5, that is the exact same thing as 2 times 3 times 5 if I multiply the 3 times the 5 first. It's still 30. 2 times 3 is 6 times 5, 30. 3 times 5 is 15. 2 times 15 is 30. They're still equal. Make sense?